Okay, take 2. What am I looking for if I'm looking for number of moles? N. Okay, so I'm looking for N. That's my question mark. Okay, they tell me it's carbon dioxide, so that can help me get big M. All right, so I got big M, carbon dioxide. Okay, and so that's going to be 12.01 plus 16 times 2, which, if my mental math is right, 44.01 grams per mole, right? 32 plus 12.01, yeah. Okay, so that's our molar mass, and the other thing they tell me is we've got 150 grams of it, so that is little m, mass. All right, so you'd get 1 mark for your givens and the calculation of your molar mass. All right, your calculation is going to be little m over big M. We don't have to manipulate because it's already set up to solve for moles, so we just plug in our numbers. 150 grams divided by 44.01 grams per mole. When I do that division, the grams are going to cancel. I'll be left with moles, okay, and we'll be looking at 3.41 moles. Okay, so you get 1 mark for that and 1 mark for your math. That would be a 3-mark question. Type 1 questions are 3 marks. Okay, questions on number 1? Okay, how many people were working on number 2 before I snatched it away? All right. Give you a couple more minutes on 2 and then we'll work through that. Okay, so type 2 question here. Okay, we're looking for the mass. So we're looking for little m on this one. Right, little m is our question mark. They tell us we have 26.5 moles. So they told us n. Okay, and it's cobalt 2 bromide. All right, so molar mass wise, CO 2 plus, Br 1 minus. So we're looking at CO Br2 is 58.93. Is that right? Oh yeah, mine like a steel trap. Okay, 58.93. And we're adding that to 79.9 times 2. Okay, so 58.93 plus 79.9 times 2. Times 2. Okay, 218.73 grams per mole. All right, so we would get a mark for that. That's our givens. Now, the mole equation is set up to solve for number of moles. I need it set up to solve for little m. What do I do with big M?
N times M.
Right, multiply, yeah. Okay, so I multiply this side by big M, it cancels. What I do to one side, I do to the other. Okay, so I multiply that side, and I would get a mark for my algebra, and then I would get a mark for plugging in all of my numbers. So 218.73 is big M, times moles 26.5. Is 26.5 moles is that a large amount of moles? It's a fairly large amount of moles. Okay, it's a lot. So when I multiply grams per mole by moles, the moles are going to cancel, and I'm going to be left with grams, the units for mass. So 218 times 26.5, okay, and I get 5,096.3, 5,796, 96 point, sorry, missing that one, 35 grams. Okay, so this is like almost 6 kilograms worth of that material. Okay, it's a lot, but it was a lot of moles. Okay, and it's always a good idea when you get a number as your final answer to question it and to look at it and go, is that number okay? Like, does that make sense within the context of the question? Okay, and go, oh yeah, 26.5, that's a lot of moles, and if 1 mole is this many grams, it's going to be a lot of grams when I'm done, and it's okay to logically think that through to kind of double check your answer. I was talking to my physics 20s the other day. I tell them to do this all the time. Like, your final answer for this question about a turtle crawling along the road says that the turtle is crawling at 300 meters per second. Does that answer make sense? That means your turtle is almost supersonic. Okay, no, that answer doesn't make sense. Okay, check your math, make sure you punched it into your calculator right. Usually, that's what it comes down to, is you just put a decimal in the wrong place, or you put the wrong exponent on a number. But if you look at a number and go, I don't like that number, go back and check, okay? Maybe it just didn't seem right and it is right, or maybe your gut reaction was 100% right and that number makes no sense. Okay, it's always good to go back and double check. Now, speaking of going back and double checking things, how important is it for you to show your work? It's important, okay? I mean, if you did this question and all you wrote was 5,796.35 grams, I would still give you 4 marks. You got the right answer, okay? And if all you showed me was that, I would say you deserve 4 marks for being a brilliant guesser. Because I have no proof as to how you arrived at that answer, but it's right. Okay, of all the numbers you could have picked, that was it, 4 marks. What if you write only a number, but you write 6,252? What am I going to give you now? A big fat goose egg. If you show no work and all you have is a number that's wrong, I have no way to give you any marks. Okay, you've got to show your work. Because sometimes it's as simple as you put the decimal in the wrong place on your calculator. Okay, you put the wrong exponent on Avogadro's number, something simple like that. But if you've shown all your work all the way along, you can still get 3 out of 4 or 4 out of 5. Okay, you only lose 1 mark for being inept at punching in numbers into your calculator. Okay, that happens. Okay, but you don't deserve to lose 5 marks if that was all you did wrong. Okay, so show your work. Right, I have this argument with kids every single year. Right? The worst case scenario, I had a kid like 10 years ago, okay? All through physics. Coderre, I don't need to show my work. I'm not showing my work. You don't need to see my work. I am that smart. And he was pretty smart. But on his final exam, when his calculator got cleared, they go back to radian mode. He needed it in degree mode. He didn't switch it back. Guy who should have got 85 got like 52. Okay, because every question that involved an angle, he got wrong because his calculator was in the wrong mode. Okay, tragic. That's why you show your work. Okay, if you'd have shown all of his work, he probably still would have got 85. He just would have had every answer wrong, but all his work would have been right. Okay, show your work. I'm going to give you marks for your work. What's the moral of the story? Show your work. Yeah, definitely show your work. Okay, type 3. Enough of my sidetrack storytelling. What special number do you need for this one? Which one?
What's his name?
Avogadro, yeah. Okay. I was going to listen because sometimes I get really funny ones like Alessandro or yeah, like I get really good. Okay, so it's Avogadro, and that number is 6.02 times 10 to the 23. So spoiler alert: at some point in that question, you're going to need that number. Okay, so in this one here, we're looking for how many molecules of sodium sulfide. So it's asking for number of molecules. Okay, and it's telling us that it's sodium sulfide, which can help us to get big M. So Na2S for that one. All right, so it's going to be 22.99 times 2, because there are 2 of them, plus 1 sulfur, 32.07. Okay, so 22.99 times 2 plus 32.07. gives us 78.05. grams per mole. Okay, so that's what we've got so far, plus we have the mass, little m, 29 grams. All right, so we'd get a mark for that. Now, I'm trying to find the number of molecules. What do I not have right now? The number of moles. Okay, so I got to find that first because I have little m and big M, so I might as well do that. Okay, so N is going to be little m over big M. That's going to be 29 divided divided by 78.05. Do I have less than a mole here?
Yeah.
All right, so it's okay that I get a decimal then when I calculate this out. And again, that's the logic you want to go through, okay, when you're doing a question. What kind of number am I going to get here? What kind of number is going to make sense in this situation? Okay, 29 divided by 78.05. All right, so I've got 0.37 moles. I'm going to keep all those decimals in my calculator, but I'm only going to write 0.37 here. Okay, so now sometimes people are like, I never know whether I'm supposed to multiply by Avogadro's number or divide by Avogadro's number. I can never remember which one I'm supposed to do. Well, here's how you can remember. I have a really small number right now, 0.371 moles. Is the number of molecules going to be a small or a large number? Large. If I want a number to get bigger, do I divide or multiply? Multiply, okay? I'm trying to get a bigger number here. I need to multiply by Avogadro's number so that I get a gigantic number of molecules, like I should, okay? I shouldn't end up with 0.275 molecules, okay? That doesn't make sense at all, right? In this case, I should multiply. All right, so number of molecules is going to be n times Av's number, okay, which is going to be 0.37 moles times 6.02 times 10 to the 23 molecules per mole. That's really what, because that's what Avogadro's number tells us, right? The number of molecules in 1 mole. So it's essentially molecules per mole. So when I multiply these things together, moles is going to cancel, and I'm going to be left with number of molecules. Okay, so my 0.37 with all the decimals in place, multiplied by that molar mass that I calculated a minute ago, 78.05. Oh, not by 78.05, times Avogadro's number, like I said I was going to do, times, in brackets, 6.02. Okay, E23, all in brackets. Now I get the number I should get. 2.24 times 10 to the 23. Okay, I made a mistake. Did I automatically recognize I'd made a mistake? I should get more than 29 molecules for this answer. Whoops, I multiplied by the wrong number. I didn't do that on purpose either. I just totally messed that up. But okay, it's a good lesson. Okay, all right, so 2.24 times 10 to the 23 would be my final answer here. 2.24 times 10 to the 23. And my units are molecules. And units are important. Make sure you put them on there. Question? All right. Questions on number 3 or type 3? Okay. Now, you got one more. Type 4 is type 3 backwards. Okay? Type 3 gives you the mass and asks for the number of molecules. Type 4 gives you the number of molecules and wants the mass. Okay? So you're basically going to do everything backwards in type 4. Okay, there you go. So, type 4 here. What's the mass of? So we're looking for, what are we looking for if we're looking for mass? Little m. Okay, we're looking for little m, and we know the number of molecules this time. Okay, so I know the number of molecules. It's 7.2 times 10 to the 23. Okay, and they also tell me that it is diphosphorus pentaoxide, which was actually one of our examples when we were learning how to calculate the molar masses. Okay, so P2O5, right, so that's going to be 30.97 times 2 plus 16 times 5. Okay, so 30.97 times 2 plus 16 times 5. All right, so 141.94 grams per mole. Okay, if I want m, little m, I need the number of moles. Okay, what I have is the number of molecules and Avogadro's number, that is basically molecules per mole. It's the number of molecules in 1 mole. All right, so let me ask you this. I have 24 donuts. How many dozen donuts do I have? How'd you do that? You divided. You divided the number of donuts you had by the number of things in a dozen. 12. 24 divided by 12. Do I want to do the same thing here?
Yes.
Yes. I want to take 7.2 times 10 to the 23, the number of molecules I have, and divide by the number of molecules in 1 mole. Avogadro's number. Okay? I'm looking for n. Number of moles should be a small number. I get small numbers by dividing, generally. Okay? So I'm going to take the number of moles that number of molecules, sorry, that I have, 7.2 times 10 to the 23, and I'm going to divide that by Avogadro's number, 6.02 times 10 to the 23. Now, if you're really clever with math, you'll realize you don't have to put in the exponents because they're the same. If you didn't catch that, it's okay to put them into, okay, most of the time you're gonna have to put them in because most of the time you're not gonna be this lucky, okay, where the exponents actually match. All right, so we'll do it the long way just so that we see everything done right. Okay, so 7.2 E23 divided by 6.02 E23. All right, should it get a little bit more than a mole? Right, 7.2 is a little bit bigger than 6.02. Okay, that's a little bit more than a mole, 1.19 or 1.20 moles. All right, so now I've got N and I've got big M. Can I get little m? Okay. So I'm going to have to take the mole equation. I'm going to have to manipulate it for little m by multiplying that side by m, and then what I do to one side I do to the other, so I multiply the other side by big M, okay, and now I can plug in my numbers. So that'll be 141.94, okay, grams per mole, multiplied by 1.20 moles, okay, the moles will cancel, and I'll be left with grams. Okay, so 141.94 times number of moles. Okay, so I get 169.76 grams. Okay, so on that one, you'd get a mark for your givens, you'd get a mark for your Avogadro calculation, you'd get a mark for your algebra, a mark for your math, and a mark for your answer. That's a 5-mark question. Okay, everybody with me on that one? Okay, are these very patterned? They are. There's 4 types. There's 4 patterns. Learn the 4 patterns, you can't go wrong. Okay? If you have Avogadro's number, you're doing either type 3, or if the number of molecules is in a question, so it says either get me the number of molecules or here's the number of molecules, then it's type 3 or type 4, and you're using Avogadro's number. If there's no mention of that, then it's type 1 or 2. You're either looking for moles or mass. Okay? All right, I'm going to give you guys about a 2-3 minute break here, okay, and then we'll move on to doing a couple of other ones and a couple of questions I want to talk about as a class. You got a question?
What are the final answer, 169? I did like 141 times 1.2.
Okay, but this is a rounded value.
Yeah.
In my calculator, I used the full value.
Oh.
And you have to, I carried it through, okay? Like when I'm writing here, I don't want to write all those decimals, so I cheat and I round off because I'm lazy, okay? But we always want to use our full number in our calculator. Yeah?
Okay.
That's why you probably got a different answer. You go, and then when she comes back, you can go. Yeah? All right, any other questions on that one? Go ahead. Yeah. Okay. So in number 5 here, we're looking for the number of molecules in 1,000 grams of water. So we were told the mass, 1,000 grams, okay? We were told it's water, so 16 plus 2 hydrogens is 18.02 grams per mole, okay? If I want to find the number of molecules, I need N first, okay? So that means little m divided by big M, so that's 1,000 grams divided by 18.02 grams per mole. Okay, so we're going to get 55.5 moles. now that we have that number, we have the number of moles, and we know that Avogadro's number tells us how many molecules are in 1 mole. So if I take the number of moles and I multiply by the molecules in a mole, then I'm going to get number of molecules. I'm going to get that big number that makes sense for when I'm talking about a number of molecules. Okay, so I multiply those two numbers together. All right, so we're looking at 3.34 times 10 to the 25 molecules. Okay, so pretty standard type 3 question. Okay. All right, question number 7. Which contains more atoms? A mole of iron or a mole of oxygen gas? Okay, so usually when I ask this question, that's the answer I get, because people look at me and go, Coder, I'm not going to be tricked by you asking which is heavier, a ton of feathers or a ton of bricks, because that's really what you're asking here. Okay, incidentally, a ton of feathers and a ton of bricks are the same mass because they're both a ton. Okay, but in this question, that actually isn't true. The question is asking which has more atoms. Iron, when it's an element, comes like that, single atoms. Oxygen gas is a molecule made of 2 oxygen atoms. So while, yes, 1 mole of iron has 6.02 times 10 to the 23 of these, 1 mole of oxygen has 6.02 times 10 to the 23 molecules of oxygen gas, each molecule containing 2 atoms. So actually, a mole of oxygen gas has more atoms in it. It's a word trick. Okay? If we're talking about the base particle, a mole of anything is 6.02 times 10 to the 23 of the smallest unit of that material. For oxygen, the smallest unit of that material is a molecule, not a single atom. Does everyone follow the difference here? Okay? It's just a little word trick. That can be like an awesome multiple choice question on a test. Okay? A, they have the same amount. B, they have different, this one has more. C, this one has more. D, it's impossible to know. Okay? Guys, by the way, if ever you get an answer that says it's impossible to know, it's probably wrong. Okay? All right. Good job today, guys. So tomorrow, remember, you'll have Miss Vespa here subbing for me, and you're going to get all kinds of good hints and tips and stuff for your unit exam next Thursday. If anybody has their reactions assignment done and doesn't want to hang on to it, I will take it if you want to hand it in to me.